السلام عليكم ورحمة الله وبركاته. بسم الله الرحمن الرحيم. Inshallah, we will go through today a revision of probabilistic reasoning, and we'll do it over a specific question. I put the slide, the PDF of the question in the slides of the lecture of the session. So if you go to the lecture slides page and you looked at the PDF files for the session 8, you will find the file called PR revision, probabilistic reasoning revision. Please download that file because that's the example that we would use in this lecture today, inshallah. Okay, so please do that and let me know when you are done. Are you done with the file? Did you find the file? Did you find the file? Okay. Okay, good. Type. So the example here, we are trying to fly a quadcopter. So we have 6 variables that we are using to model this environment. We have the weather, we have, which is W, we have the signal strength, S, we have the true position, P, we have the reading of the position, R, we have the control from the pilot, C, and we have the alarm that tells us whether there is a collision or not, which is A. And we have this base net. So W points to S, points to R, P points to R, R points to C, and then P and C points to A, point to A. Okay, so we have this base net. We have also given the values for each variable based on the question here. And now we will go through the questions together and solve them. So question number A is about representation. Number 1 under number A says what is NP, where NP is the domain size of the variable P. So what is the value of NP, which is the domain size of the variable P? So if you look at the question, the variable P represents the true position, and it is a tuple of 4 values, x, y, z, and theta. Okay, so please read the description of the variable P and tell me what will be the domain size. First, what do you mean by domain size? Domain size. We know the domain, right? The domain is the where we get the values from, right? The domain size is the total number of possible values that this variable can take. So look at now the description and tell me what is NP in that case. What is NP? So P is a 4 tuple. So P is x, y, z, and theta. Okay, it's a tuple of 4 values. Now, what are the possible values for each? How many values we have for x? Muhammad, can you pick up the mic, please? 5 values for x. How about y? Same. How about z? Same. How about theta? 4. So what is the domain size then? 19. So you added all of them. So that means that P will take one value of these 19 values. Remember that P is a position that has one value from each of these. What do you mean by before? Yes, one value for each, yes. So what is then the all possible values, all possible combinations of these values? It will be the multiplication of them, right? Because we have 5 here, 5 here, 5 here, and 4 here. Okay, so one from each. So we have 5 possible values for x, 5 possible values for y, and so on. So the total number of combinations of these values will be 5 times 5 times 5 times 4, which is NP. What we call it here NP. Okay, is that clear, Muhammad? Okay, Mustafa, is it clear? Okay, so please stop me at any time whenever there is something that is not clear. Okay, so we'll move on to the second question. Please list all of the conditional probability tables that are needed in order to represent the base net above. So we have this base net, it has 6 variables. We need now to list all the possible, CPTs, all the conditional probability tables. What are the conditional probability tables that we have here in this base net? Mustafa? I don't have so many choices today. Oh no, well, X, Y, Z are the variables here, Mustafa. So forget about this, because that's one variable. We are talking about the base net now. Okay, so you know that in base net, we have a variable for we have a CPT, conditional probability table, for each variable, right? So what is the table that is associated with W? Usually it is the variable given its parents. Okay, it's not that there is no parent, but that doesn't mean that there is no table. The table will be just P of W. We don't have any condition. It's unconditional. It's just a prior. It's a marginal distribution. Okay. Okay. How about S, Mustafa? Given W. Very good. How about P? Yeah, yes, that's correct. That's correct. P of S given W, because W is the only parent of S. P of P. It's weird that we have the same P again, but that's okay. How about R? P of R given S. Only? Oops. Okay. P of R given the parents, right? Okay, P of R given S and P. Is that clear, Mustafa? It doesn't seem to be clear. No, yeah, Mustafa. Okay, so let me say it again. Okay, so the conditional probability table will be probability of the variable, which is R. Okay, given its parents. What are the parents of R? That's it. S and P. Why is that confusing? Okay, how about C? How about A? Very good. Okay, Any questions, Mustafa, about that? Okay, so these are the CPTs that we start with in the BaseNet. Okay, so now we are done with number A. No, sorry, still we have one question under A. What is the size of the conditional probability table for R? Muhammad, what is the size of the conditional probability of R? The CPT of R. Okay, so step by step. Muhammad, what are the variables involved in this CPT? How many variables? R, S, and P. Very good. Okay, so what is the domain size of R? Which is NP, right? How about S? How about P? NP. So what is the size of the table then? It is one value from each of these three variables, right? Okay, so the combinations of them, all the combinations of them. So what will be the size? It will be multiplications of them, yes. So what is the size? So NP times NP is what? 3NP squared. Okay, so 3NP squared, yes. Okay, thanks, Muhammad. Okay, now I think we move on to question B. In question B, we want to do inference by enumeration. Inference by enumeration. It says before question B, it says, now we assume that we look at this setup from the perspective of a Spencer, a spectator who can observe A and W. So someone is seeing the value of A and the value of W, which means that A and W now became evidence. Okay, so we just shade them like that, just to indicate that they are evidence now, they are observed now. So A is bad, A has the value bad, and W has the value clear. Okay, and he now wants to infer the signal strength, okay, the signal strength value, which is S. So basically, in BaseNet terminology, he wants to compute P of S given A is bad and W is clear. We'll just say bad and clear now, just for simplicity. Okay, so that's the probability that now I want to infer. P of S given bad and clear. P of S given A is bad and W is clear. Okay, right. Now in number B, I want to do that by or using inference by enumeration. Inference by enumeration. So if Spencer chooses to solve for this quantity using inference by enumeration, what is the biggest factor that must be calculated along the way, and what is its size? Okay, so now the question is, I want to do this inference by enumeration, using enumeration, not using variable elimination. We do a variable elimination in the next question, but now I want to do it by enumeration. What would be the biggest factor, okay, that will be calculated, and what is the size of that factor? Type. If you remember, in inference by enumeration, we have to first join everything and then eliminate all the hidden variables. First, what is the query variable? What is the evidence variables? And what are the hidden variables here? And given that I want to get, I want to infer P of S given bad and clear, what is the query, what is the evidence, and what is the hidden variables? What do you mean by the query variable? The query variable is the one that we are interested in, okay, that we want to infer, What do we want to infer here? S. Yes. So S is the variable that we want to infer. How about evidence? What? Bad and clear, which are the W and A, right? And what? How about the hidden variables? The remaining ones, which are R, P, and C. Very good. Okay, Mustafa, do you have any question about that? Okay, fine. Now, in inference by enumeration, we will have to join everything, join all the factors, and then eliminate R, P, and C. Eliminate the hidden variables. Fine. To do that, we need to start with the factors. What are the factors that we should have? First, we select the evidence. So instead of having P of W, we will have P of clear, which is only the rows that have the value for W to be clear. So we have P of clear from that one. Here we have, instead of P of S the given W, we have S given clear. Here we have P of P. Here we have P of R given S and P. So now I'm listing all the factors that we have. Okay, the initial factors. The initial factors are the initial conditional probability tables. After we select the evidence. So we have these factors. We have two more, which is P of C given R. And the last one is P of A, but we observed A, right? A has the value bad, so we have P of bad given C and P, and that is the last factor. Now we want to join all of them. When we join all the factors, what will we get? If we have these 6 factors, I want to join all of them. I want to join. What do we mean by join? We multiply them together. When we multiply them, what factor we will get? When we join all any factors, we get the union of the conditioned of the unconditioned variables given the remaining variables. So what are the unconditioned variables here? We have clear from here. Of course, clear is not the variable, but clear is the value of the variable W. We have clear, we have S from here, we have P from here, we have R from here, we have C, and then we have bad, which is the value for the variable A. So we'll get this factor, right? So that's the factor that we will get first. We have to join all of them. When we join all of them, we get a big factor. That's the biggest factor ever, right? Type. What is the size of that factor? Before we answer this question, do we have any unconditioned variable? We don't, because we said that we will get the union of all the conditioned variable. We don't have any conditioned variable. We don't have anything after the condition symbol, because we got all variables here. We said that the remaining variables will be after the condition symbol, but we don't have any remaining variable. So that's the factor. Now, what is the size of that factor? Any guess? Yeah, so S is what? 6. S is 6. Ah, no, yeah. Yeah, S is 3. You told me 6 and stuff. Okay. Okay. Not clear. The clear is 1, right? Clear is 1 because now it's observed. It is observed. If it's W, then W would be 3 also. Yeah. So P is how many? 4. Why is it 4? It's NP. And R? NP as well. How about C? Okay, and how about bad? minus 1. Very good. So what is the size then? Yeah, multiplication. Yeah, very good. So that will give us 18 NP square. Okay, so we are done with question question B. Any question about question B? Okay, now we will move on to question C, which is the core question. Okay, so let me erase all of this. Okay, now we want to do inference by variable elimination. Okay, so we want to do the variable elimination in that order, R, P, C. So exactly like what we wrote here, R, then P, then C. So number 1A under C, now we are under question C. 1A, we need to eliminate R now. Which factors from the 6 CPTs above are involved? If I want to eliminate R, which of the factors will be involved? That's 1A. And 1B, describe how you eliminate the variable P, the variable R. What conditional probability factor results from this step? So the first part of the question, what are the factors that will be involved when we want to eliminate R? And in question B, we need to describe how we will eliminate it and what will be the factor that we will get out of this elimination. So any help? First, what are the factors that will be involved? We want to eliminate R now. Oops, what happened? Okay, we want to eliminate R. What are the factors that will be involved? P, R given SP, so this one. Okay, what else? P of C given R. So every factor that has R somewhere will be involved. Okay, type. Muhammad, what is the first step now? After we get the involved factors, what will be the next step? We join them. Very good. So when we join these two, what is the factor that we will get? So can you tell me what will be the variables in that factor? Okay, no, we are not talking about the size. I'm talking about what will be the variables here. So I'm expecting you tell me what will be here and what before the condition symbol and what would be after the condition symbol, if any. Okay, so how do we do it, Muhammad? We want to multiply these two, right? When we multiply these two, we get the union of the unconditioned variables. So we get R and then C, then conditioned by the rest. What is the rest here? S and P. Very good. Okay, of course we should not add R again because we have it here already in the union. Okay. Okay, now this is the factor that we get from joining these two factors. Are we done? We still didn't eliminate R, right? So we need to eliminate R. How will we eliminate R? We will sum over that table. That's a table right now, right? So let's call it F1 prime so that we can call the new one F1, the after elimination. Okay, so the factor after elimination will be F1, and after eliminating R, we will cross out R, so we will have C given S and P, and we get this by having this factor, but we sum, because we eliminated, right? We sum over R. When we sum over R of that factor, we eliminate it completely, and we get the same sequence of variables here, I mean same set of variables here, but without r. Okay, so this is the factor that we get from joining. This is the factor that we will get after we eliminate. Now, it's better to if you want to do it in one step, to do it that way. You say this is actually, instead of just the temporary factor here, you say that this is the multiplication of P of R given S and P times P of C given R. What are these two? These are the two that we joined. Okay, and now this one is F1, is what we call F1 factor here, F1 prime here. Okay, is that clear, both of you? Okay, clear, Mustafa? Type. Mustafa, you said that it's clear. Then you will do with me the next one, which is eliminating P. So we'll do exactly the same, but with eliminating P this time. Okay, so let me first, before we do that, let me erase everything here, and instead of now having these two factors, I will just remove them because we joined them already. We don't have them now. We just add F1 of C given S and P. We replace the ones that we joined with the one that we get after elimination. Okay, now Mustafa, I want to eliminate P. Yes. So what should we do? Yes. Very good. Yes, this one. 2. This one. Let's first pick the factors first. Yes. The very last one. Those are the only factors that have P. F1 also. Okay, so these three factors are the factors that will be involved. Okay, type. Next. Yes, so we will join them, right? We will join them. When we join them, we get F2 prime. It will be a factor of what? Yeah, so what should I write here and what should I write here? P, yes. Yes. Okay, that's it. Yes. Given clear. Where is clear? We don't have clear at all. How did you get clear? That's it. We don't have any. We don't have any unconditioned. Okay, so it's union of P, C, and bad, and we have S here, right? Mustafa, watch out. Okay, watch out, because if you made a mistake here, everything after that will be error, will be a mistake. Okay, so that's given S, right? And how about P? P is there. How about C? C is here already. Yeah. So that's the join. That's the factor that will be resulted in joining these three factors. Now we want to get, which is the multiplication of these three. So let me write the multiplication. That's P of P times P of, sorry, not P, F1 of C given S and P times P of bad given C and P. Okay, so that's F2 prime. Now I want to eliminate P. What should I do? So this multiplication give us this one, right? Okay, now from that one, I want to eliminate P. How can I eliminate P? I need to sum over the variable that I want to eliminate. Yeah, right? So over the variable that I want to eliminate. So sum over P of that will give me a new factor. Can you tell me the new factor? What will be in the new factor? Yes. CS, why is that? Where are you looking at here, Mustafa? Mustafa, the factor that we have now is PC bad given S, right? Now, yes, very good. So we just eliminate P. Okay, is it clear now, Mustafa? Everything is clear? Muhammad, do you have any question? Okay, so allow me to erase this now. Okay, and I also erase these three factors because we joined them. So now we have, instead of all of that, we have we have F2 of C bad given S. Okay, and that's now the third factor. Okay, right. The next step is to eliminate C. We want to eliminate C. So Muhammad, how will we eliminate C? Yes, we only have F2. So what should we do? Very good. So we have F3, which will be a factor of what? After eliminating C. Of bad given S, which will be the sum over what? Over C of F2 C bad given S. Very good. Okay. Right. Why didn't we do any join, Muhammad? Yeah, so it was one factor, so we don't have anything to join with, so we just did this sum to eliminate C. Okay, very good. Now we have, instead of this, Mustafa, do you have any question before we erase this? Okay, so now we have, instead of that factor, we have a new factor, which is F3 of bad given S. Okay. I will skip questions 4 and 5. They are really straightforward. Now question 6 is I want now to do this step. I want now to get, because we have eliminated all the hidden variables, right? We have eliminated all the hidden variables. Now we are ready to compute the value that we want, which is P of S given bad and clear. How can I do it? How can I get this probability? So after I eliminate all the variables, what should I do to get the probability that I want? After I eliminate all the hidden variables, which I did, right? So you see here in these three remaining factors, we don't have R, we don't have P, we don't have S. We don't have R, we don't have P, we don't have C. Right? So we eliminated them. Now I want to compute this quantity. this value. How can I do it? The way we do it is to join all of the remaining factors. So we join all of these three. When we join all of these three, what will we get? Mustafa. Not P. So what do you mean by P? You get a factor, right? Okay, so we'll call it F4. F4, what will be, well, it's a factor of what? Clear, comma, S, comma, bad. Do you have any condition? No, very good, very good. Okay, so we get this factor. So now this factor is like a selected join. A selected join, because we don't have any condition. All the three variables are joined, but they are selected because we have a value of clear for the variable w. So that's originally was w, right? And that originally was a. So we have a equals bad, w equals clear, and all the values of s. That's why we call it selected joint. Right, selected joint probability. Now, how can we, from that table, how can we get this table, which is P of S given bad and clear? Remember, P of S given bad and clear from the condition, from the condition probability rule. This is P of S bad clear, which is this one, divided by P of bad and clear, which is the evidence, probability of the evidence. Now, if we have the actual table, if we have this actual table, what would we do? We just normalize it. How would we normalize it? We divide the probability value by the sum of all probabilities. So we have a table like that. Actually, how many rows we would have here? S, how many values of S? We have 3 values. Okay, so we would have here S, have here W, A, S, and then the probability. So here we have, for W we have clear, clear, clear. For A we have bad, bad, bad. And for S we have 3 values, which is strong, medium, and weak. And we have a value here, value here, value here, right? So that's this factor, by the way. So if we have this table by values here, what would we do is to sum over all of these values and divide by them, so that we do the normalization. After we divide, we got P of S given bad and clear. Okay. If I want to show it by an equation, then this will be the factor, which is, I can say P or I can say F4. That's the same, because F4 actually is the probability. So I can say F4 of S bad clear divided by the probability of the evidence, which is the sum of all of these values, which is, in other words, eliminating S from that table. So it is like eliminating S from F4 of S bad and clear, so that we can get the probability of bad and clear from that table. Okay, is that clear? So this is the normalization. Actually, we did it here. We do it in the table by just dividing by the sum, which is what we have here. Okay, why we do the sum here? Because that's the probability of the evidence. When we have something like this, when we have a probability of x, y, and z, and we sum over, let's say, y, what will we get? We get P of x and z, right? Because we eliminated y by summing over all possible values of y. Same here. this part is P of bad and clear. Okay, and that's what what remains to be done in order to get the probability that we want. Okay. Any questions on this question? Is it clear for both of you, the survivors of the course? Okay. Muhammad? Okay, very good. Type. The remaining part of the question is repeating the same process but with a different order. So instead of R, P, and C, we have PCR. So we'll start with P, then C, then R. Okay. I will remind that to you. The question is there, so please do it as an exercise, but I think it will be very similar to what we did already. Then at the end, you will need to compare between the factors that you got from each of these orders, compared also with the factor that we got from the inference by enumeration in terms of size. And I think you are now in a good position to know the size of each factor. We look at the capital letters, the variables that are not observed, okay, and we just multiply the numbers of values for each, because that's the size of the table, all combinations of these variables. For example, here in that factor, we have just one value for W, one value for A, but 3 values for S, and that's why the size here was 3. The number of rows here is 3. Okay, so the last part of that whole question is asking about this comparison. Which order was better? Okay, so what will be the order? What is the criteria on which we can say that this order is better than that order? What do you think? When can we say that PCR is better than RPC or vice versa? Why? When can we say that? Based on what we can say that? Yes, what is the largest factor we can get from that process? Because the largest factor is the dominating factor. Because it will dominate, the processing of that factor will dominate the other factors. Okay, so if one of them we get a factor that has 4 dimensions, which means that it has 4 unobserved variables. That's the biggest factor we got from that order. In the other one, we got the biggest factor was of 2 dimensions. So that means that the one that has 2 dimensions is better, of course, because it's less expensive in terms of processing and memory than the other one. Okay, is that clear, Mustafa and Muhammad? Okay. Type. Any questions, Mustafa and Muhammad, about what we covered today? Okay. The last one? Yeah, sure. So we explained it in 2 ways, Muhammad. We said that this factor will look like that, right? So did you understand that this is how the factor will look like? Okay, so usually the last step in variable elimination is to join everything, which we did here, and then normalize if we have the actual table. Okay, when we do that, the meaning of that is that we divide by the probability of the evidence. Yani, when we normalize here, it's like eliminating this factor. When we eliminate this, we get the probability of clear and bad together. Okay, and now when we normalize, we divide by them, it is exactly this equation. So in doing it by the table, we do it by normalization, but this is how the normalization actually works or why it works. Okay, we divide by the sum, which is the probability of bad and clear. Why we are normalizing by the why are we dividing by the probability of bad and clear? Because of the base, because of the conditional probability. P of S given bad and clear, which is the evidence, is probability of S and the evidence divided by the probability of the evidence. Okay, so if you have the table, you can do it by the normalization. If not, like this question, you have to write it that way to show that this is how we get it. Okay, is it clear now, Muhammad? Okay, right. Mustafa and Muhammad, any question about what we went through today? Okay, by that, okay, good. By that, I think this is the end of the lecture, which means this is the end of the all lectures of the semester. I really enjoyed so much teaching this course. It's one of my favorites. I hope that you also benefited. I personally benefited from teaching the course, from your questions, and from also the topics. I now understand them much better. I also taught this session, the probabilistic reasoning session, for the first time. I didn't teach it in the previous version of the course, so it was really very beneficial to me. I hope that you benefited from the course, and that will be a motivation for you to continuing getting or gaining knowledge, or maybe working in that field. The AI field now is booming, is very hot. There are so many sub areas that are very hot now in research and even in development, as we see applications around us. Areas like natural language processing, computer vision, information retrieval, machine learning, all of these are areas under AI that are all hot, and they have very challenging and interesting problems. So I hope that that course excites you to do more in that field, and inshallah, as I told you, the machine learning course is offered next semester, so if you didn't take it, you are encouraged to take. Any comment before we stop this and leave you to see you, inshallah, and I literally mean see this time, not just talk. See you, inshallah, in the final exam, I think in maybe 10 days, something like that. Any comment at the end of the course? Thank you, Muhammad. Thanks, Mustafa. Okay, خلاص, inshallah, talk to you and see you, inshallah, in about 10 days in the exam. I wish you, inshallah, great success, not only in that course, but in the other courses also, and in your learning journey, inshallah, as well. Okay, we'll stop here, inshallah, and talk to you and see you in 10 days. Assalamu alaikum wa rahmatullahi wa barakatuh.